Okay, so welcome to part 2 of 1.1 section, where we're going to continue talking about analyzing categorical data, and we are going to discuss something called two-way tables and marginal distributions. So we'll start with an example where we'll discuss what is a marginal distribution and continue discussing how we can represent different types of distributions with categorical data. So for example 3, we have some study. It's a little bit out of date, but still we can use it. So a Pew Research Center asked a random sample of 2024 adult cell phone owners from the United States which type of cell phone they own, iPhone, Android, or other, including non-smartphones. Here are the results broken down by age category. Keep in mind, a lot of examples that we're doing are real life examples from the actual research, so that's why there is a link there in case you'd like to read that study. So, but either way, here's the results of the study from, if I'm not mistaken, 2013. So as I said, it's a little bit out of date, but still. So we have a table that shows the representation of a different cell phone type and between the ages. Okay, so so right now it's a little bit hard to read this table. So what we're going to do, we're going to find marginal distributions, and marginal distributions is the following. It's a marginal distribution of one of the categorical variables in two-way table of counts is the distribution of values of that variable among all individuals described by the table. Simply, it is percents. So basically, the table that we see in front of us, that's called a two-way table. And when I'm finding the marginal distribution, I'm finding the percents of each type of the phone that's being used. So for that, I'm just going to take each number, the total number of the particular phone users, and divide it by the total number of participants. And in this regard, we'll get 23.1%. Then we do the same thing for the different phone and we'll end up with 24.9%. And the last one will be 52.1%. Now notice that if we add all of this together, it should more or less add up to 100%. If it doesn't, that's just because of some rounding error. Okay, so these percents, this is called our marginal distribution. That's a distribution of each one of these variables, each one of the types of phone between the total number of people. We could have done the exact same thing for the ages. I could have found how the ages are distributed, but in this case, it would make no sense for us to do that because the ages is not what we're studying, and it's not going to be helpful to us in any way. Right now, we want to see how the phone usage is distributed between those three different types of phone. So once again, those percents are called marginal distribution. Now we're going to make the graph of this distribution. We're going to make a basic bar graph. Remember, when you're making any kind of bar graph, you have to label your axis. So on the bottom, we will have a type of phone. And on the side, we will have our relative frequencies. Keep in mind that when we talk about percents, those are called relative frequencies, or we can just say percents. It doesn't really matter. So right now, I'm going to draw these bar graphs. Okay, so these are the bar graphs, or this is a bar graph for our marginal distribution, and from having this visual, we can maybe make some analysis. So please notice that at least in 2013, the other types of phones were more popular than Androids and iPhones. So actually, let's answer some type of a question here. So for what type of variables are these distributions? Are they quantitative or categorical, and why? So these are categorical variables. And that's because, how do we know that? Well, keep in mind that we cannot take an average. We cannot take an average of the type of phone. So these are categorical variables because we can take the average. So, but back to what I was discussing, analyzing the graph, we can see that the other types of phones, which is not Android or an iPhone, were much more popular in 2013. However, if we put Androids and the iPhones together, then they're still not going to be as popular, clearly, but they will be close together. And it's really interesting because it's kind of hard to imagine such a thing today, just 7 years later. Okay, we're not going to do this right here. If you were in a classroom, I would ask you to do an example by yourself, but we're not going to do this clearly right now. Instead, we are going to move on to something called conditional distribution. So this one's a little bit trickier sometimes. So let's write down some definitions. So if we go back to our example about cell phones, what if we wanted to learn how the use of cell phones is used between different age groups? So right now, the data that we have, these percentages, is just purely for all of the people that was sampled, the percent of each type of the phone, how it's distributed, okay? But what if I want to have a more detailed description and to know, well, how is the types of phones distributed between different age groups? Well, that puts an extra condition of the data distribution, and therefore it's called a conditional distribution. So a conditional distribution, a quick definition, a conditional distribution of a variable describes the values of the variable among individuals who have specific value of another variable. There is a separate condition distribution for each value of the other variable. Okay, so that's what conditional distribution is. So let's look at our table again, but now we're gonna use the same data, but the question is, we're gonna calculate the conditional distribution of cell phone types for 18 to 34-year-olds. So the younger generation, let's see how the different cell phone types are distributed between them. So since the age, in this case, is my condition, when I am seeing how the phones are distributed in that particular age, I'm using the total for this age group as the denominator, as the way to divide. So we'll take 169 and divide it by 517. And in this case, I will get 32.7%. And then we'll do the same thing for the other numbers, for the other types of phones. And now we have a very, very different picture from what we had as the total, because we can see, if we're looking just at the percents, in that particular age group, the Android phone is way ahead of everything else, and iPhones are fairly close behind, and the other types of phones are fairly, quite far behind. So this is younger generation. They're using newer technology. It's still, I find it interesting now looking at this 7 years later, that Android was surpassing iPhones for that age group. I don't think that's the case these days, but I might be wrong. I'm personally using an Android type of phone. I'm not a big iPhone fan. So But keep in mind, so the conditional distributions give us a better understanding of data. So conditional distributions give us better understanding because we're breaking our data even more. So for example 5, what we found are the conditional distribution for each age group. So let's look at example 5. So based on the cell phone data, there's we have the conditional distribution for each of the age groups right here. So this is 18 to 34. That's the one that we found. But then some, ahead of time, we found the distribution for the other age groups. So the question is there evidence of difference in the distribution of cell phone ownership for the 3 age groups? And let's justify our answer. So let's look at each of the age groups. So if we're looking at 18 to 34, well, based on this data, it seems that the younger people, 18 to 34, prefer, we can say Androids, but we notice that the Androids and the iPhones, they're very close together and they're both similar high-tech phones. So we can say that they prefer Androids and iPhones. Okay, so the other types of phones, and we don't know what they mean by other, but we can imagine that it's something like BlackBerry or flip phones, things that you guys probably don't even know ever existed. But before Androids and iPhones, there were other types of, okay, so, but still, Androids and iPhones together clearly surpassed all of the other types. Between the two phones, yes, their Androids are winning in that age group, but we can have even a deeper analysis there. Okay, so then let's move on. The next, what else we can see? So people in the category 18 to 54 prefer either iPhone or Android as well. So once again, we can see that individually, so this is important, in the 35 to 54 age group, we can see it looks like the other type of phone is more popular. But once again, if we put those two higher tech phones together, if we combine the two percentages, then, so if we combine, this is a really bad color. If we combine this category and this category together, then we can see that it once again will surpass the other types of phone. However, people in the category 55 plus, they clearly prefer the other type of phones. So they're not, at least in 2013, they were not as big fans of iPhone or Android. Even if we put those together, then still the other types of phone are clearly winning. Okay. One more thing that we could say about 18 to 34 age group, now when I'm looking at the graph, we could say that the preference for the phones is more or less equal. Once again, it's tricky. We will discuss in statistics. There is a well, we talked about statistical significance, and it also could be included in determining the difference in percentages. Is the difference in the percentages actually significant, or was it just the result of some kind of a sampling variability? So in the future, we will learn to distinguish it. Just a quick taste of that to let you know. So here we have, for example, percentages such as 32.7% and 41.4%. It looks like two very distinct numbers. Clearly 41% is a higher number, but in statistics, we have this meaning of statistically significant, which basically means that statistically, even though the number looks like it is higher, it actually doesn't count as higher. So once again, we will talk about that in the future a little bit later. I think maybe even next semester. Okay, next thing that we're going to talk about are segment graphs. That I mentioned that we will discuss segment graphs or segmented graphs at some point. It's just a different way to represent our data. So let's create a segmented graph for our type of phones, and I'll do it only for one category, our 18 to 34 ages category. So we're going to create one big bar, and that's going to be 100%. Okay, that's 100%. So that's percent of the phone type used. But then I'm going to break this bar into different segments. So we have about, so let's go by 25%. So 25, 50, 75, and then 100. Okay, so this is my table. So we know that about 24, let's look at this, sorry, 25.9% of people preferred other types of phones. So this segment right here will represent our other. Then the next category we had, if I'm not mistaken, 32.7% of people preferred iPhones. So 32.7, we can add this up, and that will put us at about 57%. So this right here, this bigger chunk, biggest segment will be iPhones, and the rest will be Androids. Okay, so this is called the segment graph, and this could be useful if I also would put a graph for 35 to 54 age category right next to it, and we could have a slightly better representation of comparing between the age groups. But yeah, that's called segment graph or segmented graph, and that's a different way to represent our data. If you go to page 19 in your textbook, I think the graph for this problem is fully represented there, but I'm not going to draw this right now to save time. Okay, oh yeah, why do we need all of this? So one of the things that we really want to know in statistics is, are variables, some of the variables affect other variables. So what we mean by that is there an association between the variables? Now, some of you keep using the word correlation in your examples, and a lot of times you misuse it. So don't say correlation yet. We will talk about correlation in the future. But what you could say is there is an association between the variables. So if knowing the value of one variable helps to predict the value of another variable, we say that there is an association between the two variables. If no predictions can be made from knowing the values of one variable, we say that there is no association. Once again, forget the word correlation till later on, but you could use the word association. Once again, it means that two variables are related, which means that we could use one variable to predict another variable. For example, if we go back to our cell phones, we see that there is an association between the age group and the type of phone that's being used. For example, we see that and people that are older, that are 55 plus years old, they prefer, or preferred at least, the other type of phones different from Android and iPhone. So we can predict that an older person would rather be buying the other type of phone. However, at the same time, we can see that the younger people, 18 to 34, they did prefer the Androids and iPhones. So, we can, if we got some kind of a cell phone store, we can market newer phones to the younger generation, use that kind of advertisement, but then we can advertise the other types of phones to the older generation. So because there is once again an association between the age and the type of phone that's preferred. Okay, last thing that we're going to talk about is something called the four-step process. That is how we're going to be organizing our statistical problems. Now, this is something that we will be doing a lot throughout the entire year. Right now, some of the parts of our four-step process might seem weird to you and unnecessary, but that's because we are getting used to using that four-step process. In the future, it will be crucial for us to use it to make sure that everything that we need to include is included. Right now, once again, some of the parts you might see as unnecessary or weird, but I still would like you to follow this what's called four-step process. And the four-step process consists of, well, clearly four steps. First, we need to state our question. So basically, what is the question asking us to do? So first part is to state the question. Then we're going to plan our response. How will you go about answering the question? What statistical techniques will we be using to answer this question? Then the next part is the do part, where we're actually going to be performing our calculations or making graphs, the things that we decided we're going to use to answer the question. And finally, the conclude part is we'll make the conclusion. Once again, this four-step process is important for us so we don't miss anything. There are certain things that you have to include when you're answering a statistical question. That is also true for my tests and especially AP exam. That is why we're going through this process. So let's look at the question that we have here, which is example 6 about superpower. Okay, so in this question, we had 200 children from United Kingdom ages 9 through 17 who were selected from the Census at School website. And they were asked a question. What kind of a superpower would you prefer? And their choices were invisibility, super strength, telepathy, ability to fly, or freeze time. And what we want to know is, based on this survey, based on this data, can we conclude that boys and girls differ in their preference of superpower? Okay, so that's, I think, a very interesting question. Do they have different preferences? So we're going to do some basic analysis of this data and maybe come up with some kind of a conclusion. So, but we do need to follow our four-step process. So first, we're going to state our question. And when we're stating the question, we're just going to paraphrase it. So the question is, can we conclude that boys and girls differ in their preference of superpower? Well, we can paraphrase it in a way of, is there a relationship or is there an association between the gender and the answer to the question, what superpower do you prefer? So let's write this out. So once again, is there a relationship between association between children's gender and superpower preference? You don't have to write down both relationship and association. I'm just showing you that you can use either one of those words. Well, how can we decide this? Well, we are suspecting basically here that the gender affects the superpower preference, and therefore we're having one variable possibly affecting the other variable. Therefore, we probably should find conditional distributions of the opinions of responses for males and females separately. Okay, so let's see, so we will find the conditional distribution of each one of these superpowers, first for females and then for males. And once we find this conditional distribution, we can maybe make a bar graph where we will graph those distributions right next to each other and maybe see some kind of a relationship between the two. Okay, so let me write out the plan and then we'll discuss what we can do next. Okay, so we suspect that the gender could influence the superpower preference. So we will find, once again, conditional distributions of responses for males and females. So let's look at our table. How do we find conditional distributions? Well, for each gender, we'll divide their preference, the number of people that prefer that particular superpower, by the total for that gender. So we'll take 17 and divide it by 115, and we'll get a percent there, which is about 15%. And then we'll do that for the next one, which would be 3%, and so on. And we'll do the same thing for the males. So we have 85 males here. So we'll divide every one of their responses by 85. So it's about 15%, and so on. So let me fill out the rest of these distributions. Okay, so here we have the conditional distributions. Once again, we took the total number of females and divided each one of the responses by the total number to find the percents. Just in case you did not know, this symbol, this is not a very good, this symbol right here means approximately, because the percents came out to be decimals. Also, you might have noticed that I changed the color from red and blue for females and males to some more gender neutral colors. I did not do it on purpose to begin with, but then I noticed that I'm just falling into gender stereotypes, and we don't need to do that anymore. It is 2020 after all. So anyway, so we have the distribution of the powers based on gender. It's a little bit hard to make any conclusions here, though we do see some things. So let's create a chart or a bar graph for these distributions, and then we can analyze it. So in our do part, we already found the conditional distribution, so we can see, say, C table for conditional distributions. Okay, so we know where to look, so we did not have to write it all out. So when you do your homework, it might be easier for you to maybe copy the table down and show your conditional distributions in the table rather than writing it out in a list. It's also would be probably easier for me to read. So and now let's create a conditional distributions bar graph. So here on the bottom, we will talk about the type of superpower. And on the left side, we once again going to talk about relative frequency or percents. Let's just use percent symbol here. We don't need, that would be clear enough. But remember, always label your axis. Okay, I will draw the bar graph right now and show, we can see what's going to be there. Okay, so based on our data here, we created this bar graph. So I tried to keep the colors the same. So the green ones are the females and the purple ones are males. You can see that I also showed that here. So please make sure that whenever you create your bar graphs, you label everything so I can see what's what. It doesn't, I'm not going to be measuring with a ruler how, whether your bars are truly representing your percents or not, but, it should be more or less obvious. Also notice that I, of course, labeled all of the actual superpowers here. So we have invisibility, super strength, telepathy, flying, and freezing time. So now let's see what kind of conclusions we can come up with. So first of all, we can clearly see that invisibility right here, invisibility is exactly equal. So the boys and the girls are very equally likely to choose invisibility. We also can see some big discrepancies in some powers. For example, boys are much more likely to pick super strength or freezing time. We can see that there is a big discrepancy between males and females here. On the other hand, we can also see that girls are more likely to pick telepathy or the ability to fly. Okay, so there is some kind of a connection between the gender and the type of powers that they can pick. We cannot make any cause and effect conclusions right now. We don't know enough statistics for that, but we can see from the graphs alone that, once again, super strength and freezing time superpowers, that boys are much more likely to pick those. Girls are more likely to pick telepathy and the ability to fly, and they're equally likely to pick invisibility. So let's write this out. That would be our conclusion. Okay, so we just wrote out our conclusion. Let me repeat this once again. Boys are more likely to pick super strength and freezing time. Girls are more likely to pick telepathy and ability to fly. And we can say, interestingly, both boys and girls are equally likely to pick invisibility. So that's about as much of the analysis we can do at this point. In the future, we can come up with more analysis than that. But right now, that's all we can really say. Okay, so once again, please remember that there are two types of distributions that we've talked about today: marginal distributions and conditional distributions. So marginal distributions is when we just finding the distribution of the total variables. Conditional distribution is when we're putting an extra condition on our distribution. So once again, marginal distribution would have been just finding the total. Sorry, for marginal distribution, we would have been finding the total distribution of each one of these superpowers between both boys and girls. So marginal distribution are these percents right here. So that's how the powers in general are distributed between the kids, which, still something interesting to look at. But then if I want to be more specific and find a distribution of powers, of superpowers between the actual boys and girls, then that's what we did earlier, where we divided the total number of boys by how many picked specific superpowers, and then we took the total number of girls only and divided it by how many of those picked a particular superpower, and that gives us a little bit more insight on um, the information that we have. Okay, anyways, so this is our lesson for today. Please do your homework. Notice that there are two questions that I will be grading in this assignment. Let me know if you have questions, and have a wonderful day.